How is a buyer to choose from these items, each one claiming to be the best? Price is one major consideration. But which would be the best buy for a given price? That is, which is of better quality? What does the buyer or user expect from the product? These expectations can be generally expressed quite objectively and specifically as performance standards or any other criteria like, does it have a nice color? How does it perform? Or does it have any snub value for me? This is the external aspect of quality that concerns the user, and it can be defined as fitness for use or purpose. There is a second aspect that concerns the user, and that is mass production. The user expects any of the apparently identical items to be identical enough, and all of them must conform to what was specified. So, quality for the user can be defined as conformance to specifications. The aspect of quality that mainly concerns the producer, especially of mass production, is how to maintain quality. At this point, it is essential to know what does the term quality mean.
Quality, in my opinion, is fitness for use. Each product is meant to satisfy certain uses as perceived by the target customer. If product satisfies all those uses for which it is meant, as again perceived by the target customer, the product can safely be called as a good quality product. The next point is how to really achieve this good quality. The most of the Indian industry give a lot of thrust on inspection, and they feel that if there is a good inspection, we can definitely have a good quality product. In my opinion, this philosophy is totally wrong. We cannot have good quality only through inspection. Yes, it definitely helps, but putting a lot of thrust on inspection will definitely not lead to good results. Primarily because a good inspection not necessarily mean a good quality product, and secondly, it is impossible to get good inspector who can inspect the job with 100% surety.
There are basically three major stages in production of a commodity. 1. Raw materials and other components. 2. The manufacturing process. And 3. The workforce. Modern quality management is a sophisticated system that uses value engineering and other concepts to define the nature and quality of inputs to be used to produce the end product.
At the time of designing a product, you design the quality into the product, and normally a product which is designed in quality and also takes care of the process in which it is going to be manufactured will always be well produced, because it is designed with the process in mind, and what all quality is ensured by a good process and good design. Therefore, there is no need for a control. So the EPFDX product in question, the initial design has the equipment was 3 times as bulky as the present size. The reasons for it are the following. One, we used a iron core transformer rather than a ferrite core transformer. That reduced the volume. That changes not only reduced the volume, but also increase the performance, as the ferrite core transformer in communications has inherently better characteristics and better features. Number two, the printed circuit boards used in the product originally were of different sizes. With the result, the elegance in assembly and the size of the product was high, and also the reliability in terms of alignment, etc., were improved by making the size of the all printed circuit boards to be the same. And the third, some of the integrated circuits were later on incorporated to remove certain discrete transistor circuits. These were not only reducing the cost, but also enhance the reliability considerably.
In the manufacturing process, the same component or item can be made by different processes, costs, and quality. So, the manufacturer must choose a process which will produce at the lowest cost and that which conforms to the specifications laid down to meet the user's requirement. Every process has inherent limitations, and this capability can be described statistically, and so can the variability in the quality of performance or output. So, a manufacturer must know what he can expect from a production machine or process. This knowledge enables the manufacturer to do two things. One, to determine what combination of machine, material, and men will most economically produce maximum customer satisfaction through the product. And two, how to maintain the quality of the end product by controlling the process of the various stages of production. Let's take a look at a production line and how quality checks, statistical and other methods, and quality control techniques are used.
Divided the stuffing stage into various parts. Idea is simple, that if we ask one operator to put in 300 components or 400 components, the amount of mistake committed will be very high. We make them in simple stages, make the proper drawings for them, and each operator is supposed to complete her part of it. And since she is doing this job repeatedly, the chances of committing mistake are few. After stuffing, the PCB passes to an area called masking area. Then the board goes to the inspection area. A lot of emphasis is being given to make it right first time. Various displays are there on the working stations, which keeps on reminding the people as to what is the correct way of performing the job. So mistakes committed at this stage are very few, but since repair is difficult later on, it's essential to pinpoint those things here. The board is inspected and corrected, then it moves to the soldering machine, wherein the soldering of all the components which have been stuffed takes place. After wave soldering, the board passes to the cleaning area, wherein the flux which has come during wave soldering is removed. The clean board then passes to clearance area, because there are certain components which cannot be mounted and soldered on wave soldering machine. They are hand soldered, but such components are very, very few. And at each stage of inspection, we have displayed a board wherein the faults pointed out by inspector they are displayed on the board. This board serves as a source of immediate and accurate feedback to the point of occurrence. As soon as board comes to the inspection stage, the feedback goes to the point of working, and they make a course correction, and then similar faults are not repeated. After clearance inspection, the board goes to the electrical testing area, wherein each and every board is electrically tested on certain jigs. So now we have OK boards available for final assembly. We have another integration area where all the mechanical assemblies are assembled as per the process sequence displayed on their respective station. Now this assembly and the boards, they go to the final testing area where the integration is done and the whole system is tested. The full system goes to the soak room. The condition inside soak room is 45 degrees centigrade throughout the year, and each system is placed there for 5 days. We also put some EPROMs to run the system artificially as if the exchange is working, and we try to find out if there are any failures during running. The idea of doing this test was to clear all the teething problems which are inherent, which could be inherent in the system. After this soak, the system again comes to the system testing area, wherein there is a retesting done, and then we try to locate if there were any failures during soak test. Generally there are not, because enough care has been taken on the preceding stage. After this we do the final QC. Now we have got a concept of plant CE, it's called plant customer engineering, and they do or they handle the equipment the way customer would have handled. They even misuse the equipment sometimes, and once they clear the system from customer angle, the system is ready for dispatch.
What about the worker? That major factor in ensuring quality. Machines and materials are best controlled objectively and ruthlessly. But how is a worker to be motivated? There is now a consensus among practitioners, academicians and scholars that while new technology continues to be a major factor in improving quality and productivity, it suffers from some limitations. That is, unless human factors adapt to technology, the growth process can neither be sustained nor accelerated. If change has to take place, let us prepare the workers and all others to face it squarely and with a willingness to be adaptable and flexible. Towards this, a wide variety of participative forums in the nature of small group activities or quality circles have proved more viable than many complex techniques of planning and execution.